got about 17 minutes till this advent of code problem starts, so we'll be hanging out, wait until that happens. So to solve these problems, I'm going to be using Python in Visual Studio Code. Last year there were two-part problems. First part should probably be pretty easy. We'll see if we can tackle the second part. When this timer expires, we'll read through the problem and we'll start the challenge. I'm not going to be going for any leaderboards. We'll probably see why pretty shortly here, but we're going to be on the hunt for stars. Pretty late, don't know if I'll be ready for all of them when they first come out, but we are going to do our best. Hey, my name is Barrett. I'm going to be doing some coding today. Just a couple minutes to go left here. I'll show you my file structure. I've got some directories, a couple Python files, empty text file. We expect maybe there could be some data, maybe we'll have an example to work with, and then we'll come up with a solution. Just some template files that we'll be working with to solve the problem efficiently. Oh man, this is exciting. All right, let's go. Day 1, Historian Hysteria. The chief historian is always present for the big Christmas launch, but nobody has seen him in months. Last time I heard he was visiting locations that are historically significant to full. A group of senior historians has asked you to accompany them as they check places they think that he's most likely to visit. As each location checking, they will mark it on their list with a star. They'll figure the chief historian must be in for they figure the chief historian must be in one of the first 50 places to look. So in order to stay Christmas, they need help them get 50 stars on their list before Santa takes off on December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Good luck. You haven't left yet, and the group of senior historians has already begun. Their list of locations is checked is currently empty. Eventually, someone decides that the best place to check first would be the chief historian's office. Upon pointing the office, everyone confirms the chief historian is indeed nowhere to be found. Instead, Alice is starting notes and lists of historically significant locations. This seems to be finding the chief historian is moving forward left. Perhaps these notes can be used to determine which locations to search. Throughout the chief's office, the historically significant locations are listed not by name but by a unique number called location ID. Make sure you're seeking historians for the two groups, each taking office, and trying to create their own complete list of location IDs. There's just one problem. By holding the 2 lists up side by side, your puzzle's input, it quickly becomes clear that the lists aren't very similar. Maybe you can help the historians reconcile their lists. For example, so this will be our input. Oh no. So this will be our input, example input. So we've got these lists. Maybe the lists are only off by a small amount. To find out, pair up the numbers and measure how far apart they are. Pair up the smallest number in the left list with the smallest number on the right list, then the second smallest left number with the second smallest right number, and so on. Within each pair, figure out how far apart the 2 numbers are. You'll need to add up all of those distances. For example, if you pair up a 3 from the left list with a 7 from the right list, the distance apart is 4. If you pair up a 9 with a 3, the distance apart is 6. In the example list above, the pair distances would be as follows. The smallest number in the left list is 1, and the smallest number in the right list is 3. The distance between them is 2. So we're going to put these lists in order. We're going to put these lists in order. We're going to find the distance between these 2 lists. The total distance is the sum of those distances. So for the example input, they're expecting 11. So these lists are probably pretty big. We're gonna first have these 2 text of lists. We want to get them into into some text file. We're gonna just see. Okay. Well, that's good. Yeah. Okay. So we're gonna get these lists. We're gonna take our example. So we're gonna get our example file here. Yeah, we're probably not going to be cam on, I think, the whole time. We're going to do with open. This is like a context manager to handle the file opening in read mode. Read. What we do. So what we can do now is we can print and see if we are close to doing this right. So what we should expect to see is this will print out in the console. So it looks like we do have our input data printing out to the console. So what we are doing here is we've got these strings, and these strings look like this. We want to format them as lists. So what we might do is we could look at every line and say split it up with a white space and then join two lists. That's probably going to be good enough for the example, and that might be good enough for 1 star. Let's start with that. So we'll loop for each line in the data. So we want to separate at the new line. Now in this line, we're going to separate the two, the left and the right list. That should give us what we want. And then we're going to, these are not the list rather, but the number. We are going to set these both to empty lists. It's a right value and a left value. And then we're going to put each of these in our lists. We'll append it on the back. So once we have these in our two lists, we're going to expect we should be able to sort them pretty easily. Once we've got all of these through all the lists, or all the lines in our list, we're going to print these two lists. That looks better. So now we sort these lists, and we are going to compare them for this distance thing it's looking for. How are we going to sort this? We could, we can just sort this, right? Yeah. So this might be, this is going to be slow, but we don't have a lot of numbers right now. So that is going to be okay. Now what we're going to do is for each of these elements, let's say the left and the right element. Zip these two sorted lists together. And then we're going to calculate the distance And it didn't sound like it cared if it was going to be negative or not. So this will calculate the distance. We'll also add a total distance. Total dist. After we get the distance for each of the pairs, we're just going to add it to the total distance. Total distance. Let's see how we did. Oh, so it looks like this is probably going to do this in place. That'll be okay. So we are going to name this instead to same thing. And then we're just going to delete this. So these are strings. We got them from this text file. So we gotta make them like they were all integers. We're gonna make them integers. 0. Nice. Okay, so we were kind of expecting. Let's see what we were expecting. 11. So what we could do is we could print out each distance we calculate. We're getting a lot of zeros. Let me sure it's working. So you can also visually have a better look. Yeah, I don't know how this sort works. Well. Oh, okay. Yep. Okay, yeah. No sweat. 11, easy every time. Well, we feel good about 11. So we are going to use this as our starting point. Oh yeah, so that was for the example. The example is useful because we can use the small size of the problem. Oh yeah, so that was for the example. The example is useful because we can use the small size of the problem to visually see what's going on. Just a handful of numbers that you can sort and calculate the difference for in your head. So for the puzzle input, we'll see that these numbers are bigger, seem to be longer. Looks like they're all still integers. And then the same format, left column, right column, 3 spaces. We're going to select all this, and then we're just going to copy this into a new file. We just want a new file. That looks like that copied. Oh, good. So we're going to go to the solution. Done with the examples. So now we're going to instead give it the input.txt with the actual puzzle input. Right. So this is what we calculate using the same thing. I I screwed this line a little bit here, and you saw it. I didn't expect that. So we're gonna try this. See how it does. Ooh, nice. 1 gold star. So as we saw a little bit earlier, there are a number of folks who seem to have finished. We're gonna keep pushing on. There's still another star to be had. Part 2. Your analysis only confirmed the two lists of location IDs are indeed very different. Or are they? Historians can read, made a mistake, or how to read most of the location handwriting. But in question notice and interesting detail, a lot of location IDs are in both lists. Maybe the other numbers aren't location IDs at all, rather misinterpreted handwriting. This time, you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left lists after multiplying it by the number of times it appears in the right list. Okay. Let's maybe go through the example here. We got the same list again. For these example lists, here's the process of finding the similarity score. The first number in the left list is 3. It appears in the right list 3 times. So the similarity score increases by 3 times 3 equals 9. The second number in the left list is 4. It appears in the right list once. So the similarity score is increased by 4 times 1. 4. Okay. So in the example, they are getting a similarity score of 31. So it doesn't look like we're going to be sorting these anymore. But we are still going to be kind of traversing these a little bit back and forth. Let's look at how that's going to work. So this is going to be part 1. And let's just duplicate this for part 2. So part 2 is going to start out kind of similar. Let's make sure we're calling the right function here. So now we're not going to be sorting. Well, I guess it doesn't. Ooh, it could matter. It would probably be faster to sort it. We can do it this way. We don't need to sort it. So we're still going to work through each list. We are. How do we only look at the first list? Okay, so we're getting the numbers from the list and the occurrences in the right list. So we're just going to start in the left list. So we're gonna say, okay, so for each element, how many times does the left element occur in the right list? I think we can say contains count. Let's do a count. So this is going to be the counted portion. And the number, so numeric score, well, that's just the element. So the total score, they call it similarity, well, the similarity for each of these So this is going to be a little similar. And we're going to add that to this here. So if that looks all right, we're going to, we better change this back to our example input and make sure that our logic is working correctly with this small data set. So we were looking for 3 and we are, or 31, and we are getting 31. So that is a pretty good indication. We're going to try now with the regular input. I think that's what's going on. There's like some lines getting cut off. That's another gold star. Hey, great job. We did it. So, as I mentioned, we're going to try to get some more stars. This might be the hardest one to edit because this is probably going to be the only one I edit. So, well. Look who decided to show up. Interesting. So I guess you can also view your rank here. So you get a score if you're in the top 100. Otherwise, you've just got your rank. But it shows your time as well. Couple this is tough.